We're going to do something a little bit different. We can't have some of these units last for a couple of days or more. So I think during your asynchronous time, we're going to try and get a little preview of the next section. So you're getting this when you're getting the lesson for 2.3, and during your asynchronous portion of class, you're viewing this video and answering some questions about it. All right, so I'm hoping that we can at least stay on pace as best as we possibly can and not get far behind, because we don't want to do that when we do come back into the classroom. All right, anyway, so we're going to get a little preview of 2.4, complex numbers. Now, what is a complex number? A complex number is a combination of a real number and your imaginary unit, which is I. Now, you all have seen I before. I is a symbol that represents the square root of -1. Now, what is a complex number? Well, I just mentioned that a complex number is a combination of a real number adding or subtracting the imaginary unit. Okay, for example, 4 plus 6i would be a complex number. All right, now, one of the things that you're going to have to be able to do is you're going to have to be able to add and subtract complex numbers. And that's done exactly the same way as we would do variables. For example, if we did 5 plus 4x and we wanted to add that to 9 minus 2x, well, you'll combine like terms. 5 and 9 is equal to 14, and positive 4x and negative 2x is equal to a positive 2x. All right, so you're going to do the exact same thing here. So, for example, here's an actual complex number, 3 minus I plus 2 plus 3i. Well, you'll combine like terms. 3 plus 2 is 5, and you'll combine the i's. So negative 1i plus 3i is equal to a positive 2i. All right, that's basically all it is. Keep in mind, though, if you're subtracting, let's say I subtract 4 minus I and 7 plus I, don't forget that you have this minus sign out here that needs to get distributed through that following set of parentheses. So what we end up getting is plus negative 7, and that's a negative I. So 4 minus 7 is negative 3, and negative 1i minus I is negative 2i. All right, so don't forget that when you do have a minus sign here, you do need to distribute that negative to make sure that you get the correct answer. When you're multiplying complex numbers, it gets a little bit complicated. So let's just kind of go through some basics of I and its powers. So I to the first power, that's equal to I, which is also equal to the square root of -1. I squared, well, that's going to be the square root of -1 times the square root of -1. Well, basically what we have here is the square root of, whoops, I messed that up, sorry. We have the square root of -1 squared. Now, we all know what happens when a square root is squared. They cancel out. So we end up getting -1. If we have I to the third power, that's the same thing as saying the square root of -1 times the square root of -1 times the square root of -1. Well, we already know what these two is equal to, so we did it up here. So these two right here is equal to -1 times the square root of -1. Let me just rewrite that back in as I. So this is I times -1 is -I. And then I to the fourth power is the square root of -1 times the square root of -1 times the square root of -1. I'm getting a little redundant here, square root of -1. Well, again, I know what that's equal to. That's equal to -1. I know what that's equal to. That's equal to -1. And -1 times -1 is +1. What happens here, first off, this is all you need to know how to do, because what happens here from here on out, I to the 5th power is equal to I to the 1st power, which is I. I to the 6th power is equal to I to the 2nd power, which is -1. I to the 7th power is equal to I to the 3rd power, which is equal to -I. And I to the 8th power is equal to I to the 4th power, which is 1. So it just starts repeating. It repeats the first 4. And we just go on and on and on, repeating that. And it's very helpful for you to understand that because of this repeating, I can find the value of I raised to any power I want. Let's say raise it to the 37th power. Now I don't need to write this out 37 times. All I need to know is, first off, it repeats every 4. So if I divide 4 into 37, I get 9 with a remainder of 1. So I can go through this 9 times, 9, okay? And then it ends up right here. So I to the 37th power is equal to I. So remainder of 1 represents the first power. If I did I to the 42nd power, then I'll do 42 divided by 4. That's 10 with a remainder of 2. So this 2 right here represents the power of 2 right here, which is equal to -1. If I get a remainder of 3, then my answer is this. If I get a remainder, well, you should not get a remainder of 4, but if you happen to get a remainder of 4, it's this. Or if it divides evenly with no remainder, it's still this. Okay, so when you're multiplying complex numbers, you need to keep this in mind. And we'll probably end up talking about that a little bit more in class. So let's just do an example of multiplying complex numbers. Let's say I do I times -3i. Well, when you're multiplying when you're multiplying variables with coefficients, you multiply the coefficients together, and then you multiply the variables together by adding their exponents. Well, this has a coefficient of 1. 1 times -3 is -3. This I has an exponent of a 1. This I has an exponent of a 1. So I times I, 1 plus 1, is 2. Well, we already know what I to the 2nd power is. I to the 2nd power is equal to -1. So what I have now is -3 times -1, which is equal to 3. I can do that in my calculator. I times -3i, and I get 3. All right, so it could be done in a calculator too. If I was going to multiply this, the square root of -4, times the square root of -16, well, we already know that there is no square root of -4. That's a non-real number. But if I would not, what I'm going to do this the correct way first, and then I'm going to do an incorrect way, because there's a rule that you guys should remember. But anyway, I'm going to simplify this using I. So I know the square root of 4 is 2. And what I have left over is this. So square root of -4 is equal to 2i. I know the square root of 16 is 4. So what I have left over now is this. So the square root of -16 is equal to 4i. Now what I have is 2 times 4 is 8. I times I is I squared. And then we already know I squared is equal to -1. So 8 times -1 is equal to -8. All right. Do not do it this way. I want to do this in red, and I want to just say that this is wrong. So hopefully this sticks with you, and if you start doing it this way, you'll realize, oh no, this is wrong. All right, one of the rules about multiplying radicals is if they have a common index, this does have a common index of the 2 and 2, then you can multiply the radicands together. If you multiply the radicands together, -4 times -16, I get, what's that, 64, positive 64. And I would think that, oh, I'm going to get 8 as my answer. But no, you can't do it that way, not with complex numbers, not with the imaginary unit. You're going to have to do it this way instead. So this is wrong. All right, so the rest of this, we're just going to go ahead and do in class. And you're going to go through this video. There will be some questions for you to answer. Okay, hope you have a great rest of the day, and I'll see you for 2.4.